Hello students, in our previous lecture we study about asymptotes and now in this class we will study about the curvature. Curvature means to study the nature of arcs of the curve at different points. As we see in these different curve, as we see in this curve, the bending of the curve at every point changes. At this point the curvature is different, at this point the curvature is different, at this point the curvature is some another different. In this curve also, at this point curvature is high, at this point curvature is low, and at this point curvature is very low, and at this point curvature is high. Now if we consider the circle, then the curvature at every point is equal. So we will study for a different type of curve the curvature. Now to study the curvature we study about the radius of curvature also. The radius of curvature means if we take at this arch and follow this arch and make the circle, then the radius of that circle is known as the radius of curvature. Now it is evident if curvature is high, then radius of curvature will be small, and if the curvature is low, then radius of curvature will be large. That means radius of curvature is the reciprocal to the curvature. Now according to the equation of curve, we have some formulas to find the radius of curvature. If the equation of curve is given in Cartesian form, that is as is this form, y will be as a function of x, then radius of curvature will be 1 plus y1 square whole raised to the power 3 by 2 upon y2. Here what we mean by y1? y1 is nothing else dy upon dx, and on the same way y2 is nothing else but second order derivative of y with respect to x. No, if the equation of given is in implicit form means implicit function of xy, then radius of curvature will be fx square plus fy square whole raised to the power 3 by 2 upon f double x fy square minus 2 times fxy fx fy plus f double y fx square. Here this denote partial derivative of f with respect to x, this denote partial derivative of f with respect to y, this denote partial derivative of double partial derivative of f with respect to x, and this is single partial derivative of f with respect to y. This denote double order partial derivative of f with respect to x and y. Similarly, this denotes the partial derivative, double partial derivative of x with respect to y. Here we do partial derivative of f and substitute the values in this formula to find the radius of curvature when the equation of curve is given in implicit form. In the third case, if the equation of curve given is in parametric form is like that: x is equal to function of t, y is equal to some another function of t. Here t will be called the parameter. To create the relation between x and y, we take t as a parameter, and the radius of curvature in this form is given by x dash square plus y dash square whole raised to the power 3 by 2 upon x dash y double dash minus y dash x double dash. Here x dash stands for dx upon dt, y dash stands for dy upon dt, y double dash stands for second order derivative of y with respect to t, and x double dash stands for second order derivative of x with respect to t. Now let us do some examples. Now let us take an example. The equation of curve is given: y is equal to 4 sin x minus sin 2x. This is the form Cartesian form, where y is given as a function of x. So our formula to find radius of curvature will be 1 plus y1 square whole raised to the power 3 by 2 upon y2. Now first we compute y1 and y2. y1 means derivative of y with respect to x, and y2 means double order derivative of y with respect to x. Now differentiate this with respect to x, we get 4 cos x minus 2 cos 2x. Again differentiate it with respect to x to find y2. It's become minus 4 sin x plus 4 sin 2x. Now we are to find the radius of curvature at this point. X is equal to pi by 2. Then we find the value of y1 and y2 at this point. Now put pi by 2 in y1, so cos pi by 2 become 0, and if you put here pi by 2, it's become cos pi. Cos pi means minus 1, so minus 1 into 2, it becomes 2. Now put x is equal to pi by 2 here, we get sin pi by 2 1, and here we put pi by 2, it's become sin pi. Sin pi means 0. Then here y2 become minus 4. Now at pi by 2, put these values y1 and y2 in this formula, we get radius of curvature of this given curve at the point pi by 2 is this. Now taking one more example, we are to find the radius of curvature of this curve at this point, and we have to show that radius of curvature is equal to 2a. Now here the equation of curve is in implicit form. This equation of curve is given in implicit form as function of xy, mixed function. Now in this implicit form, we are to find radius of curvature, and the formula for implicit form is fx square plus fy square whole raised to the power 3 by 2 upon f double x into fy square minus 2 times fxy fx fy plus f double y fx square. In implicit form, we use this formula to find the radius of curvature. So we have given f is equal to this. First we compute its partial derivative which used in the formula. Fx means partial derivative with respect to x. So to differentiate this equation with respect to x, we consider y as a constant and x a variable. Similarly to we will find fy by considering y as a variable and x as a constant. Now if we find fy, then derivative of y is 1 and x square as it is. This both are treated as constant, so derivative of this term is 0 and derivative of this term is 2y into a. Similarly f double x means derivative of this with respect to x, so it become 2y minus 2a. Double derivative of y, differentiate this equation partially with respect to y, derivative of this term become 0 and derivative of this term become minus 2a. Similarly fxy means derivative of this term with respect to y. If we differentiate this with respect to y, this term become constant and derivative of this term become 0 and derivative of this become 2x. Now we are to find the radius of curvature at this point minus 2a. 2a means put the value of x minus 2a and put the value of 2a in this derivative and computing, then fx becomes minus 4a square, fy becomes 0, f double x becomes 2a, and double derivative of y with respect to y become minus 4a. Now substitute these values in this formula. After substituting these values, its radius of curvature becomes minus 2a. Because radius of curvature or radius is a positive quantity, so neglect the negative sign. The numerical value of radius of curvature is 2a. Again consider one more example. the equation of curve is given x is equal to a cos cube theta, y is equal to a sin cube theta. So here the equation of curve given in parametric form, and here theta is the parameter. So in parametric form, the radius of curvature will be given by this formula: x dash square plus y dash square whole raised to the power 3 by 2 upon x dash y double dash minus x double dash y dash. Here x dash means derivative of x with respect to theta, and y dash means derivative of y with respect to theta, and y double dash means double derivative of y with respect to theta, and x double dash means second order derivative of x with respect to theta. So to find the radius of curvature, first we evaluate all these values. Here we have given x is equal to a cos cube theta, y is equal to a sin cube theta. So differentiate x with respect to theta to find the value of x dash. The derivative becomes a constant 3 cos square theta, and derivative of cos theta is minus sin theta. So x dash value becomes this. Now y dash, differentiate this with respect to theta, a constant, derivative of this becomes 3a sin square theta into cos theta, as 3 becomes here and 3 sin square theta, and derivative of sin theta is cos theta. Again differentiate this with respect to theta by using product rule, and x double dash become this and y double dash this. Put these values of x dash, y dash, x double dash, y double dash in this formula, and solving, then we get the radius of curvature rho is equal to this, and as the radius is a positive quantity, so 9a square sin square cos square theta whole raised to the power 1 by 2, that means under root of this. Under root of this become 3a sin theta cos theta, and here cos square theta plus sin square theta become 1. So numerical value of radius of curvature is 3a sin theta cos theta. To find the numerical value, we neglect the negative sign. So by these examples, we see that by using these formulas for different type of equation of curve, we find the radius of curvature for those curves. These are the general formulas to find the radius of curvature, and to find the value of radius of curvature at a some specified point, substitute that point in these values to find the radius of curvature. Now to find the radius of curvature of any curve, first we see the nature of the equation of curve. If the equation of curve is given in Cartesian form, then we use this formula. If the equation of curve given in implicit form, then we use this formula to find the radius of curvature. And if the equation of curve is given in parametric form, then we use this formula to find the radius of curvature. Now you try yourself to find the radius of curvature of different type of equation of curve and solve the equations.